Solving problems to making decisions to imagining completely new ideas, our thinking processes shape every part of our lives. Today, we're breaking down exactly how thinking works and how creativity fits into it. This is Module 2.2a: Thinking, Problem Solving, Judgments, and Decision Making, Concepts, and Creativity. In this lesson, we'll explain what cognition really is, how concepts help us simplify our world, and how prototypes and schemas influence the way we categorize information. Then we'll explore what psychologists know about creativity, including how divergent and convergent thinking work, and the factors that help creativity grow. By the end of this lesson, you should be able to 1. Define cognition and explain the functions of concepts, and 2. Explain the factors associated with creativity and describe some ways of fostering it. Let's start with cognition, which refers to all the mental activities associated with thinking, knowing, remembering, and communicating. Every time you solve a math problem, remember your password or describe your day, you're using cognition. Psychologists also study metacognition, which literally means beyond cognition, which is thinking about your thinking, monitoring and evaluating your understanding and performance. Research shows that students who use metacognitive strategies, like self checking on learning, tend to perform better academically. Another major part of cognition is forming concepts, mental groupings of similar objects, events, ideas, or people. Without concepts, every chair, every fruit, and every emotion would feel like a totally new experience. Concepts simplify our world. Most concepts are built around prototypes, are mental best examples of a category. A robin is a more prototypical bird than a penguin, so we recognize robin equals bird faster. Our prototypes can even shape our memories, like in studies where people misremember blended face as being more prototypically white, Asian, or male. We also rely on schemas, mental frameworks that help us organize and interpret information. Schemas help us predict what will happen next, but then they also create biases, especially when applied to groups of people. Jean Piaget explained how schemas form and change. Assimilation happens when we interpret a new experience using existing schemas, like a toddler calling every four legged animal a dog. Accommodation is when we adjust our schemas to fit new information, learning that dogs, cows, and cats are different categories of four legged animals. These two processes help us understand and update our understanding of the world. Now, touching on the second learning target, we go into creativity, which is the ability to produce ideas that are both novel and valuable. It's not only about art, creativity appears in science, writing, problem solving, and everyday thinking. Aptitude tests like the SAT require convergent thinking, narrowing options down to one correct answer. Creativity, on the other hand, relies on divergent thinking, which expands the number of possible solutions. Tasks like name as many uses for a brick as possible depend on divergent thinking. Sometimes our past experiences limit creativity. This is called functional fixedness. If you can only see a brick as something used in construction, you might not realize it can also be a doorstop or a makeshift weight. Psychologist Robert Sternberg identified five components of creativity: expertise, a deep knowledge base; imaginative thinking skills, seeing things in new ways; a venturesome personality, taking risks; intrinsic motivation, being driven by interest, not rewards; a creative environment, having support, collaboration, and space to think. All of these ideas, concepts, prototypes, schemas, and the components of creativity are things we actually use every single day. When we meet someone new, we automatically match them to one of our schemas, like teenager, teacher, or customer, and that affects how we expect them to act. That's our concepts and prototypes working behind the scenes. We also use creativity more often than we think. Divergent thinking helps us come up with multiple ways to study for a test, solve a conflict, or even plan our schedule when things get busy. Ad Sternberg's five components show up in school all the time, from building expertise in a subject to taking risks in class discussions to finding internal motivation for the things we care about. These real life examples show how closely thinking, problem solving and creativity are connected. And that brings us to a real research study that looked at why some students struggle to actually use strategies in new situations. The study we're using is by Barkowski and his colleagues, 1989, titled General Problem Solving Skills: Relations Between Metacognition and Strategic Processing. The goal of the research was to understand why students, especially students with learning disabilities, often learn a strategy in class but can't apply it anywhere else. So the big question was, is the problem a lack of strategy or a lack of metacognition? Teachers had noticed a pattern. Students could memorize a strategy well, but the moment the task changed, the strategy disappeared. Barkowski's team wanted to test whether metacognitive skills like planning and monitoring were actually the missing piece that allows students to transfer strategies to new situations. The participants were children and adolescents with learning disabilities, usually in elementary or middle school. These students were chosen because they often showed the exact problem the researchers were interested in. They could perform a strategy during practice, but they couldn't generalize it to the new tasks. The researchers designed several training programs. Students were placed in different instructional conditions, including strategy instruction, learning the steps of a problem solving strategy, self instruction training, teaching students to talk themselves through the task, attribution retraining, shifting beliefs like I failed because I'm dumb to I didn't use the strategy yet. Executive function prompts, reminders to plan, check work, and reflect. After training, students completed two types of tasks: near transfer tasks, which were very similar to their practice tasks, and far transfer, which required using the same strategy in a new situation. Here's what the researchers found. Most students could perform the strategy during practice, which shows they did learn it. But on far transfer tasks, many students completely stopped using the strategy. When researchers added metacognitive coaching, the results changed. Students were taught to monitor their thinking, ask themselves questions, and reflect improved significantly on far transfer tasks. This showed that teaching a strategy alone isn't enough. Students need metacognition to know when and how to use that strategy in new contexts. Overall, the study demonstrates that flexible problem solving requires more than memorizing steps, it requires metacognition. This ties back to creativity too. Transferring strategies, adapting ideas, and thinking in new ways depend heavily on being aware of how we think.